So Multiscripts integrates randomized pragmatic clinical trials within the Swiss MS cohort, transforming the way we treat patients towards more personalized care strategies. Our first cycle of evaluation focused on 6-monthly monitoring of NFL, and NFL is a biomarker of disease activity, which combined with routine clinical assessment might inform more personalized treatment decision, resulting in better quality of life and less disease activity for patients. Recruitment is ongoing. We have currently randomized over 650 participants in just under a year, and we have reached 70% of our planned sample size. But Multiscript is more than just a unique trial. By combining clinical research and routine practice, we've created a learning healthcare system in which... Wow.
Thank you very much. And the next one.
The green?
Okay.
Okay. So what if we can find a switch between immune balance and immune chaos? Instead of looking into the manifestations of MS, we looked into pattern recognition receptors, so one step behind these manifestations of MS, and we played our cards right, and we were able to identify and target a specific pathway with an inhibitor, and applying it on EAE mice, we were able to completely protect them against disease development. And now we're moving on into the clinical development. As you can see here, our CNS that is damaged, and we are trying now with our inhibitor to keep the structure as it was. We cannot gain function, but at least we can keep it in a more healthy way. Thank you.
Thank you. Okay. Perspective changes everything. If you look at the object, you can see that from one side, it gives you a shape of a triangle. From the other side, it gives you a square shade. The object actually didn't change at all, but the perspective, the way how we looked at it, changes everything, and we can study the object better. And the same basically applies to multiple sclerosis. So for years and decades, everyone was studying autoreactive T cells, recognizing protein antigens, basically myelin. But actually we know that majority of the central nervous system is made out of the lipids. And specifically, sulfatide can be an interesting target. Therefore, we decided to actually develop some methods to study lipid autoreactive T cells, specifically sulfatide reactive T cells. And indeed, we figure out that in peripheral blood and also the cerebrospinal fluid in MS patients, these cells are present, and they are more present than, for example, in healthy donors. And that's all. Thank you very much.
Hello. On our poster, you will find new data of our project investigating the role of complement activation in MS. So we found in the past that complement activation is increased in MS and is also associated with disease severity in MS. And now we found that it is also associated with GFAP, which is another biomarker which is associated with disease severity. And also higher levels are associated with brain atrophy and with a higher rate of paramagnetic rim lesions. Altogether, these data support the concept that complement activation is associated with disease severity. It might be a new target of, or complement inhibition might be a new target of new treatment options. Thank you very much.
Thank you. Around 80% of people with MS experience fatigue. Yet our understanding of its pathophysiology is still fairly limited, and this profoundly impacts therapy. Among the potential mechanisms, we have structural brain lesions, peripheral and central inflammation. A novel theory also suggests that metacognition, as well as a loss of control, might play an important role in explaining why fatigue arises in a context of chronic dyshomeostasis. The FAMRI study aims to assess the evidence for these different mechanisms by collecting a plethora of data modalities and, using machine learning, trying to predict fatigue scores on unseen, held-out data.
With this, we're able to discern which features, which variables of which data modalities most robustly predict fatigue. Find me at the poster session if you'd like to know more. Thank you.
So during your medical consultations, you probably all develop the feeling, sorry about that. My brain has pre-aged probably. You all develop the feeling if the person in front of you has prematurely aged or is actually younger for his or her age. And from the structural MRI data, we know that structural parameters change over time. And we know that there is evidence that chronological, biological age can vary. So to objectify this subjective impression, we apply CEST, chemical exchange saturation transfer, to measure metabolites, lipids, macromolecules, and we generate maps to map them on the brain. In a preliminary analysis, we explored the value of this marker in a prospective cohort of glioma patients and found significant associations between markers and the aging.
And that's it.
I lost time.
You should go.
See you at the poster presentation.
Thank you very much.
The immunopathogenesis of multiple sclerosis is as yet incompletely understood. We chose to focus on the interplay between EBV infection, autoantibodies, and neural cell damage. In this end, we confronted human-induced pluripotent stem cell-derived astrocytes and neurons to serum and CSF of people with MS to detect autoantibodies targeting these cells and analyze these results together with clinical and paraclinical parameters describing the state of MS and of anti-EBV immunity in said people. The goal was to identify separate profiles of people with MS. Most notably, we found that the presence of anti-neuron autoantibodies, as previously reported for NFL, correlated with MS activity, while the presence of anti-astrocyte autoantibodies, as previously reported for astrocytes, correlated with chronicity of disease and disability. Thank you to the MS Society for your support.
Thank you.
Oh, am I supposed to do this?
You have to do this, yes?
Okay, hello,
It's your
good morning.
presentation.
Good morning. It is my presentation. This is my presentation. How to treat older persons with MS with disease-modifying therapies, or DMTs, truly is a puzzling question, for there is no consensus. What I'll tell you today is how they are treated in Switzerland. And to uncover the pieces of this puzzle, we analyzed 3 years of data from the Swiss Multiple Sclerosis Registry. We found that almost 1/3 of our participants did not use a DMT for the past 3 years, whereas close to half of them have continuously used the same treatment. Smaller groups have either stopped, switched, or newly initiated a DMT within the last 3 years. Among those who have continuously used the same therapy, most commonly used was ocrelizumab, followed by fingolimod and dimethyl fumarate. If we simplify this to no DMT versus DMT use, neither age nor MS duration were significantly associated with DMT use, whereas MS type was, suggesting that in Switzerland, to treat or not to treat really is a complex decision, not solely guided by the passing of time.
Excellent.
Good morning, everybody. In my research, I'm looking at phagocytosis, specifically in microglia and monocyte-derived macrophages. Using a mouse model of MS, I block this pathway on the different cell types. And please come to my poster, and I will show you a little bit more about it.
Wonderful.
So when we study MS disease courses, we often resort to EDSS course, and we look for confirmed disability worsening. And in the MS registry, we were wondering whether we could come up with a similar algorithm for health-related quality of life. And we are using an instrument that is called EQ5D that also covers pain, anxiety, daily activities, self-care, etc. And indeed, we created an algorithm, I spare you the technical details, that found that in about 4% over the course of 4 years developed this kind of worsening. And what was interesting, is also that this type of worsening was highly associated with depression and pain. So it's very meaningful also, and it complements existing EDSS measurements. And again, for the details, please come to my poster. And now we go to lunch, right? No?
Not quite.
Not quite. Thank you.